All right, we're on page 7 of our 8.2 notes. We have one more set of functions that we're supposed to show our inverses. So remember from the previous page, we have to first do f of g of x. So we replace g of x with what it's equal to, which is x plus 7 cubed. Quantity cubed, I should say. So what we're really finding is what is f of x. Whoops, I need a separate parenthesis, don't I? X plus 7 cubed. So this means go into f. Wherever I see an x, plug in that quantity, x plus 7 cubed. So really what I'm doing is taking g and plugging it into f. That's why it's called a composition, and finding the new value. So this would be cube root of x plus 7 cubed. So one thing I notice is students forget to take the x out. This is a substitution. You're taking x out and putting the new x in its place. And then we have the minus 7 outside. So remembering from chapter 6, these undo each other. Cube and cube root are inverses. So that x plus 7 pops out because if we have 3 of something under a cube root, it comes out as a single. So x plus 7 minus 7 is simply x. Ta-da! So we have half the problem done. We showed that f of g of x is x, but in order to show their inverses, remember we have to also show g of f of x is x. They both have to be x. If one is x and one's not, then they're not inverses. So let's do the second one. The second one is g of f of x. So we're going to take f of x out and replace it with what it's equal to. It's equal to the cube root of x minus 7. And make sure that minus 7 is not underneath the radical, just like it's not here. So what we're ultimately finding is go into g. Wherever you see an x, replace it with cube root x minus 7. So I go into g. I'm going to take the x out, and in its place I'm going to put cube root x minus 7. So what's that going to look like? Everything else stays the same. Parentheses are there. Take the x out. Replace it with cube root x minus 7. And then we have the plus 7. And then we have parentheses cubed. So everything else is written the same. We just take that x out, replace it with the new x. So cube root x minus 7 plus 7. So these are gone. And then we get cube root x cubed. So again, these are inverse operations. They undo each other. So my answer is, ta-da, x. So now that we've shown they're both equal to x, then we can say that f and g are inverses. So everything undoes it. That's why they're inverses. Minus 7 plus 7, inverses. Cube root x cubed, inverses. So they all undo each other when they're truly inverses, and we just get x. And you will see that quite often in the next class. So that is something in one of the units you will be doing. So to show functions are inverses, we have to do both the compositions and show they both equal x. Okay, next we're going to learn how do you find an inverse. So we just learned how to test to see if functions are inverses. How do we find an inverse? And it's a simple little 4-step process. This is, again, something you'll do quite often in the next class. So f of x is y. So that makes sense, step 1, because we don't want f of x in there. We want a y, because remember, the definition of inverse is to switch the x and y. So that's why we need a y in there instead of f of x. So first replace the f of x with y. Then we know the definition of an inverse because we highlighted it on the last page. The definition of an inverse is to switch the x and y. So when they're asking us to find the inverse, it makes sense that step 2 would be interchange x and y because that's the definition. Then we solve that new equation for y, and then we replace the y at the end. So we're just undoing this step, but we're replacing it with f inverse since we interchanged x and y. So let's do those 4 steps here. So step 1 is replace f of x with y. We did it. Step 2 is make the y x, make the x y. So the y became x, the x became y. Step 3 is solve. So if you remember from chapter 5, whenever one side's a fraction, we make the other side a fraction so that we can cross multiply and set our cross products equal. So we get x times 3y minus 1 equals, going this way, we get 7. And, oops, I skipped too many steps. So they multiplied both sides by the LCD here. So they multiplied by 3 minus, but we get the same thing. So x times 3y minus 1 is 3xy minus x. And going this way, we get 7. So let me just do my way just so you can see the steps. So x times 3y minus 1. So that's the first cross product, equals the second cross product, which is 7. And then from there, that's where they got this. So I cross multiply rather than use LCD, but you could multiply both sides by the LCD too. It's the same thing. And we did that in chapter 5. We did both ways. So just put the whole number over 1, multiply the numerator times the denominator. We get that. Multiply the denominator by the numerator, and we get that, and we set those two equal. And it's using this principle, just to remind you, when you're solving proportions, you set your two cross products equal. AD equals BC. So I want to go back to the beginning. That's why this worked. So both sides are fractions. One cross product equals the other cross product. Then we distribute 3xy minus x. Is that equal to 7? And then step 3 above says solve for y. So that means I need to get the term with a y all by itself. So that requires that we add x to get it over to the other side because I need y all by itself on the left-hand side. So that produces this, 3xy, this will cancel, equals x plus 7 or 7 plus x. And then to get y alone, we have to do the opposite. So this is 3x times y. So we divide both sides by 3x. And 3 cancels, x cancels, so we get y equals x plus 7 over 3x. And then the last step is to show the reader that you found the inverse. So replace that y with f inverse of x. So a little teeny bit of algebra. So first we make f of x y. Then we cross multiply. And whoops, I'm getting ahead of myself. So first we make f of x y. Then we interchange our x and y because that's the definition of an inverse. So the y became x, the x became y. Then we need to get rid of the fraction, just like we did in chapter 5, which means cross multiply and set your cross products equal. Then distribute, get y alone, and that is your inverse. So we show the reader that it's the inverse by replacing y with f inverse of x. Because remember, y and f of x are the same thing, but since we interchanged x and y up here, we now call it f inverse. So it looks complicated, but you'll see it's not a hard process at all. So let's practice on some. It's easier to practice from the beginning than to jump in on someone else's work. And try to follow it. So step 1 from the other side is replace f of x with y. Step 2 from the box on the other side is we're finding the inverse. The definition of inverse is interchange x and y. So we're going to make this x and we're going to make the x y. So that's just like when we did the ordered pairs and we switched the order. We made the y x and the x y. So first 2 steps, super easy. We already know f of x is y, and by the inverse, y becomes x and x becomes y. Step 3 is solve for y. So since we're solving for y, I'm going to flip this around because I like the letter I'm solving for on the left. Miss Anal here. So this is a great problem because it also pulls in some of our chapter 6 material. So I need y by itself. That means I need to get rid of that radical. So we learned in chapter 6 to get rid of a radical, you undo it. So to get rid of square root, I square, but if I square the left side, I must also square the right side. So I'm just solving this radical equation, and we learned to solve radical equations by undoing the index. So undo a square root would be square. So the reason we did that is because they undo each other. So now we get y plus 6 equals x squared. So step 4, or part of step 3, is get y alone. So to get y alone, we subtract 6. So we get y equals x squared minus 6. And for the final answer, we let the reader know what we found. We just found f inverse. So we write f inverse of x equals x squared minus 6. And that would be our final answer. So as I said, it's not really that hard of a process. So let's just go through the steps one more time to make sure everybody's on the same page here. So that's step 4, by the way. So step 1, make f of x, y. Step 2, replace the y with x and the x with y. All the rest you know how to do because they're from previous chapters. So I just flipped the equation over. So step 3 is solve for y, get y alone. And so we have a radical. We learned in chapter 6 to undo a radical. You do the opposite of the index. So the opposite of square root, or the inverse of square root, is squared. But we learned if you squared the left, you must also square the right. So squaring the left cancels that because square rooting something squared, it just pops out of the radical. And we get x squared. Then we subtract 6 because remember our goal is to get y alone. And then step 4 is show the reader what you found. I've just shown that if I graph this and I graph this, then I know that these two will be mirror images of each other. I do need to put a restriction on the domain though. Remember how this has to be positive under a square root? So when we do domain, we say, and this is on your final exam, by the way, is finding the domain of a radical. We say this can be 0 or positive. We can't have a negative underneath, otherwise we have an imaginary number. So 0 or positive means greater than or equal to 0. So that means x must be greater than or equal to negative 6 in order for that to be true. So x must be greater than or equal to negative 6. So that's called finding the domain of a radical. And like I said, that is a question on your final exam. So anytime we have a square root, whatever's under the square root can be 0 or a positive. It can't be a negative. So this is how you write 0 or a positive. Greater than or equal to 0. Subtract 6 from both sides. And so that is our domain. X must be greater than or equal to